Alright, so in this lesson we are going to look at some questions on half-life or activity and the best relation to use and the calculations involved as well. Is that okay? So I have 3 sample questions here. The first one, if 1 gram of a certain radioactive isotope disintegrates to 0.025 grams. So if 1 gram of a certain radioactive isotope disintegrates to 0.025 grams in 10 minutes, what is the half-life of the isotope? What is the half-life of the isotope? So we are looking at the solution for the first question. But before that, we need to understand certain terminologies used in the question. So if 1 gram, it means that 1 gram here indicates the initial amount of the radioactive isotope. Is that okay? So the 1 gram here represents Rn naught. Is that okay? So it disintegrates to 0.025 grams. So the 0.025 gram here indicates Rn in 10 minutes. So the 10 minutes here is the time, T. Is that okay? What is the half-life of the isotope? So over here we said T half is equal to ln 2 over K. So we know that our T half is equal to ln 2 on K. Or T half is equal to 0.693 over K, where K is the decay constant. So in this question, before we can get our half-life, we need the value of what? K. How do we get the value of K? We have N naught and then we have N. We also have T. Is that okay? So looking here, we need K. How do we get K? So we can use any of the relations here. We can use this. We can choose to use this. So let's use the third relation. So in our third relation here, we have ln of N naught over N is equal to KT. Is that okay? Now, what is our N naught in the question? In the question, our N naught is 1.0 gram. What is our N? Our N is giving us 0.025 grams. And then what about our T? We have our T to be equal to 10 minutes. Is that okay? So we have N naught, we have N, and then we have T. It means that we can calculate for what? K. Do you get the point here? Alright. So we have ln of N naught over N is equal to KT. So you are going to get ln of, into brackets, N naught is 1 divided by N, that is 0.025, bracket close, is equal to K times 10. Is that okay? So we can then punch our value on the calculator. So we have ln in brackets with a fraction in numerator 1 divided by 0.025. And then we close the brackets. We are going to get 3 points. So we have 3.689 per approximation to 3 places of decimal is equal to 10K. Is that okay? It's equal to 10K. So we are going to continue over here. So after our substitution, ln of brackets with the numerator 1 over 0.025 will give us 3.689. You can do that as well. And this is equal to K times 10. That is what? 10K. Is that okay? So we are continuing over here. So we have 3.689 is equal to 10K. So to get K, we divide through by 10. So our K will then be equal to what? So let's look at answer, or simply 3.689 divided by 10. So 10 here will eliminate 10 here. So our K will then be equal to 0.3689 per minute. So these are value for the K. Is that okay? But in a question where we asked to calculate for K, no. We were asked to calculate for what? The half-life. But we know that half-life is equal to ln 2 on K. So we needed a value of K before we can calculate for what? Our half-life. Then we continue by calculating our half-life by T half is equal to ln 2 on K. So therefore our T half will be equal to ln 2 divided by 0.3689. Now let's punch this on the calculator. We have ln 2 divided by 0.3689. And that is equal to 1.88 minutes. That is to 2 places of decimal. So our half-life, our T half, is equal to 1.88 minutes. Is that okay? So that is the answer for our first question. That is 1.88 minutes to 2 places of decimals. Is that okay? To 2 places of decimal. So in a question we're asked to calculate the half-life. So if 1 gram of a certain radioactive isotope disintegrates to 0.025 grams in 10 minutes, what is the half-life of the isotope? And we know the relation in calculating half-life is given by half-life is equal to ln 2 on K, or half-life is equal to 0.693 divided by K. Is that okay? But we don't know the value for K. So it means that we need to get the value of K. And with the information given to us, we're given the initial amount of the radioactive isotope, that is the N naught. We're given the final amount after disintegration, that is the N. And we're given also the time for decay, that is the T. So corresponding to any of the relations here, we can calculate the value of what? K. Once we get the value of K, then we then put it into the half-life relation to get our half-life. Is that okay? Please, are we good? Thank you very much. Let's look at our second example.